We have exactly 10 minutes. And within these 10 minutes, we shall complete chapter 9. So pay attention, since it's in paper 2. We spoke about coordinates, what they are. You know how to place them in a graph. We also know the standard form of a linear equation. We also know how to recognize a linear equation. Now we're going to talk about a parallel line. Now, what is a parallel line? A parallel line, if you look on the floor, the tiles are parallel to each other if you look at the lines. Yes, so if you look at the tiles, they are parallel. Parallel lines never touch or intersect with each other. This or these are parallel lines. They will never intersect. Now, what is intersect? Intersect means they will do this. This is called an intersection. This is an intersection. Yes? Parallel lines will never do this. They will never intersect. Straight line. Never intersect. So if I have an equation, for example, the line Q, look very careful at how it is written. Because if you're going to write something else than I am writing, then it is wrong. This is how you identify the line Q. Yeah, so if I say line Q, this is how it is written. Q dot y equals 3x plus 7. We know the standard form of a linear equation, which is y equals mx plus c. That's the standard form. There it is. M stands for the gradient. C stands for the starting point. So, if I ask you, what is the gradient of line Q? The gradient is not 3x. The gradient is 3. Not 3x, it's 3. That's the gradient, it's 3. I have a specific line, I shall say, line Z is what? Parallel to line Q. And goes through the coordinate let's say A, 0, 1. And then follows the question, give the equation of line Z. Something like this can even come in a paper 1. It's that simple. It takes you about 10 seconds to figure it out. When a line is parallel, or when lines are parallel to each other, they have the same gradient. In order to show if a line is parallel, they can do, or CXC can do this, and then say Q, Z. So that indicates Q is parallel to Z. Yes, as you can see, those two lines, they're parallel. So if Q is parallel to Z, that means Z has the same gradient. Oh, that's easy. So Z, there is Z. What is the equation of Z? Y equals, same gradient, 3x. There it is. 3x plus C. But we're not finished because I still need the C. If we remember correctly, what is or how do I find C? I find C by placing 0 at the x value. So if I place 0 here, 3 multiplied by 0, it should pop out the answer of C. Wait a second, it is given. So when x is 0, y equals 1. So that means when x is 0, what is my answer? My answer is 1. So 1 equals C, that's it. So what is the equation of Z? Y equals 3x plus 1. Bam. Parallel lines. This comes 90% times in a paper 1. 90% of times in a paper 1. Takes you 2 seconds to figure it out. Parallel line, same gradient, 0, 1. Oh, C is 1. Done. I did it in depth. Normally this takes you 10 seconds to figure out. Same gradient, x is 0, y is 1. So 3x plus 1. Easy peasy. Following parallel lines, there is another equation, which is the most important and the one you most likely are going to get, which is a perpendicular line. We have parallel lines. What is parallel line? Same gradient. Same gradient. A perpendicular line means you have two lines which form a 90-degree angle with each other. That's a perpendicular line. So let's say this is line A and this is line B. They form a 90-degree angle. I've seen this many times in paper 1s and 2s. As I said, chapter 9 is the chapter you get the most points for. It's about 4 to 5 equations. You get the most points for chapter 9. So it's always best to know chapter 9 the best. Perpendicular line. So if line A were to be 3x plus 7, and the exercise would state line B is, that's the sign for perpendicular, is perpendicular to A. B is perpendicular to A. You have an equation. That means the gradient of B, line B, the gradient of B equals the gradient of A multiplied by the gradient of B, and that answer is -1. That is the formula. That is one you always have to remember. This gives you about 2 points. This is always in conjunction with what I'm about to explain next. So you have a specific line, line A. You have another line which is perpendicular to line A. How do you find the gradient of line B? You take the gradient of A multiplied by the gradient of B, and that should equal -1. And all of you would say, but teacher, I don't have the gradient of B. That is correct. That is why you use algebra to solve this particular equation. Because what do I have? I have the gradient of A. That I do have. So what does the formula become? 3 multiplied by the gradient of B, which I don't know what it is, equals -1. 3 multiplied by what is -1? Let's say we place x. 3x is -1. X is -1 divided by 3, which your answer and then becomes -1/3. It doesn't get any simpler than this. Gradient of the one you know multiplied by the one you don't know equals -1. That's how I remember it. Parallel lines, perpendicular lines. Once you receive chapter 9, it will always come in the test, always. One more extended than the other. So you can get 2 pages of just chapter 9. Perpendicular and parallel. All right. We have 3 more to go, and then you can make all exercises in chapter 9. All of them. The third one. You have a specific line. Line. Let's make it ascending. You have 2 coordinates. I would like to know the linear equation that belongs to these 2 coordinates. Something like this gives you about 3 to 4 points. 3 to 4. Which is always in the test as well. Let's do 2, 6. So I have space. Yes. So where is A? This is A. Where is B? B is here. I would like to know the linear equation that belongs to the two coordinates. This is my x value, and that is my y value. The distance on the x-axis, stay with me, the distance from the x-axis from A to B is what? Is 2. The distance is 2 in the x-axis from A to B. The distance from A to B in the y-axis, the distance from A to B in the y-axis is 4. So the first thing you need to find is the gradient of the line. Second formula, or third. Teacher, what is y1? What is y2? Easy. The first coordinate has a y, so that becomes 1. The second coordinate also has a y, so that becomes 2. And then we go to the x values. I have x2 and x1. Well, we go back to the first coordinate. That is 1. I go back to the second coordinate. Oops. And that is 2. And there you have your formula. y2 minus y1 divided by x2 minus x1. So, what does it become? 6 minus 2 divided by 4 minus 2. Answer. The distance, here we are. They can sometimes give it to you in a graph. Most of the time, they will just give you the coordinates. Most of the time. 4 divided by 2. The gradient of the line that passes through what? Through A and B is 2. So y equals, what was the standard formula? mx plus c. So y equals, what is the gradient? Gradient is 2. 2x plus c. Teacher, I'm still missing the c. You are correct. So we are going to find it. How are you going to find it? By placing one of the two coordinates in the equation. And there's a specific way of writing it. It's a very specific way. You have A, which is 2, 2. It's the way of writing. Do not forget. The first two was the x value. The second two is the y value. So my y is 2. 2 equals, let me change the 2's so you can see a difference. I'll choose purple. Equals 2 multiplied by the 2 plus c. Just filling in the coordinates. This is 2 and that is 2. So 2 equals 4 plus c. So 4 plus what equals 2? C is negative 2. This is how you find the equation that belongs to this exercise. So today, these are the 3 things we've done today. Oops, lines.